So there are all sorts of ideas. There are much fewer ideas that you need to just survive this course. Once you see the exam, perhaps that's what worries me. You will feel that you don't need to do too much in this class. Really, again, it's so we talked about product rule. I spoke a little bit longer to my other class regarding the stand double thing, regarding the linear approximation, and it was clear to me that many people were not imagining enough of it. So for a moment, I will actually go through the definition again, definition of the derivative of product rule. So when I take the derivative of a product of two functions, guys, I see this is my function, right? So I plug in z into this function, subtract f, the function with x inside, divided by z minus x. And within this expression, I am seeking f of z minus f of x over z minus x, and g of z minus g of x over z minus x. Because those expressions, by hypothesis, I know their derivative is f prime and g prime respectively. So here is the situation. We have that in this limit we have z's together and x together, and we actually, if we create a mix x and z, we will be able to break this formula apart. You understand? So you have to have a goal. It's like if you're lost in the forest and you're walking aimlessly, you will not get anywhere. So you have to understand what is it that we are looking at. In this expression, I want to find this pattern and this pattern, because those patterns I can reduce the formula for. And so I subtract fxgz and add fxgz, so that it's not, and then look at it, guys. So this part is what I have here. I just break it, I can factor out gz out, and this part here, I get this part out. Good? So then finally, I make the observation that I have gz times this expression, which is the derivative, and fx times this expression, which is the derivative of g. Now the limit as z goes to x of g of z is g of x. That's not immediate. This is true because the function g is differentiable and therefore is continuous. So let's quickly see how this formula works, guys. Right? So the way this formula is supposed to go is that what I do is, if this is f and this is g, then it's very easy to remember. The formula for the product rule is f prime times g plus f g prime. So you can imagine the prime is like a traveling salesman. It moves from first function to the next function. Okay, so please write in the comments, calculate derivative of x squared times e to the x. I just want to see that you are able to follow the formula. This is the formula that is derived above. Yeah, I want to see as many of you possible. So first, let's see that you can follow the formulas. Okay, great. Great. Okay, at least this part seems that you are getting. Just how the formula is. guys, again, right, listen to me. If you are stuck at anything, last time after the last lecture, I stayed. So the lecture was over at 7:45. I stayed with the students until 9:45. Right. So I usually don't even leave until the students go. So we talk to them as long as we need to. Thank you, Stephen. There were initially 10 students and at the end only 2 in the office hours. We can really discuss anything when we have more time. If you are stuck at anything, if something is, if you feel unhappy because of something, you can talk to me. I hope you understand that I am not indifferent to what happens to you. Otherwise, I would not be getting upset when you don't give a damn about the material. So the answer is, as some of you have written, it's f prime. F is x squared. Derivative of f is 2x, and then we have g plus f. We don't touch it. Derivative of g just happens to be that derivative of e to the x is always e to the x. That's what we established through quite a few lectures. Alexa, by the way, good morning. I haven't seen you in a while. Okay. So then I wrote a few examples. I don't want to go over them. They are somewhat silly examples. You can actually make it a bit simpler. Okay, guys. So here is, if you have to, unless I say derive something by definition, if I say take the derivative of something, you can do it in any which way you like. You don't have to go by definition. I do hope that, of course, you are going to try to establish the formula. So here I apply product rule because here is what we have truly learned. Here is what we have really understood. You see the whiteboard? Yes, guys. So what I truly have understood is this. If I have x to the power of 5, for example, right, the derivative of that is 5x to the power of 4. I know that, right? So this is a product rule that we established. Remember the Nightingale story. We established that. And that's true for any x to the power of a positive integer. If I take the derivative, then it's n x to the n minus 1. That's what we have established. Good. Now, it is very simple to establish. So just before I go on, guys, what if I wrote x to the power of 1 over 5 and I press the derivative, what would I get? Write in the comments, please. What would I get? Thank you, Joshua. Come on, the rest of you guys, write if you know what you would get. Thank you, Christian. Thank you, Ping Ping. Yuzu, thank you. Stephen, thank you. David, thank you. Lisha, thank you. Khalil, Jonathan, Ying. Thank you, Alexa. Thank you. Okay, so yes, you do get 1 over 5. One over 5 x to the power of 1 over 5 minus 1. You can simplify it to minus 4/5, right? Yeah, so it's the same thing as 1 over 5 x to the minus 4 over 5. Yes, that's what we get, but it is something that you need to, you see, it's not an integer power, so you can be suspicious. Maybe the formula fails to work, right? If you have something like now x to the power of minus 5 and you take the derivative, right? Minus 5 is not an integer. What you get is it's actually ends up being minus 5x to the minus 5 minus 1. It ends up true, even though, again, Strictly speaking, I hope you noticed that, guys, right? Strictly speaking, we only established that with the Nightingale story for integer powers, right? Positive integer powers, not negative integer powers. So for all of those ideas, you have to provide a separate proof, okay? And then of course, if I have in general, if I have, let's say, 2/5, if I want to take the derivative of 2/5, notice it's not like 1/5, it's now the ratio of two integers. It does happen to be 2/5 x to the power of 2/5 minus 1, but it requires a separate proof. You see, I'm trying to say, not only for caution, I just want you to be discerning here, right? Here is the situation in general that we will establish partially. I just do not know how much you can appreciate such things as you're just learning the material. If you have x to any alpha, right, it will end up being the result that if you take the derivative, then that's alpha x to the alpha minus 1. So for example, if I have derivative of x to the pi, whatever that means, that would be pi x to the pi minus 1. But we have not established it. I hope you understand, guys, right? So some of you are like, oh, I don't care, established or not, but maybe most of you are like this. But I hope to change that. I hope to understand that to use mathematics and love it, you have to understand it. And that's what we are aiming for. Okay. So back to our discussion. So you see, in some sense, taking the derivative of x to the 1/3 times x squared using the product rule is clumsy, right? It's not comfortable. Do you agree? I do it using the product rule. Why? Because strictly speaking, in A, again, I remind you, we can establish what is the derivative of x to the 1/3, and I already know what's the derivative of x squared, right? I can establish more and more shortcuts. I can try to generalize the power rule to any alpha. But again, when it's not on the exam, when it's not when you're not required to be rigorous, you can solve problem B this way. You can say that it is x to the power of 1/3 plus 2, and therefore its derivative is simply 1/3 plus 2. You can simplify it if you prefer. X to the power of 1/3 plus 1 plus 1. Good. So that's how you can solve it. And some, of course, some of you might be, if you notice this thing and you know this pattern, you might be, maybe annoyed by what I wrote in the example. It's just we have so few functions. I delayed talking about trigonometry, and there is very little examples I can come up with that you can differentiate. There's polynomials, and there is what else? That's pretty much it. And then there's rational functions of sorts, right? And only few of them, not all the rational functions. So that I hope explains to you why what I do over here. Here I remind you how to take the derivative of 1/n. This is the definitional way. I showed you the geometric way, and that's the geometric way is extremely important, guys. Okay, and here I just use product rule because I'm saying that I do not know how to differentiate the combined function, strictly speaking. I haven't established the rule, right? But the rule always holds. Good. So you guys just yes, that will equal to the derivative of x to the 7/3. But guys, do you understand my fine point is that if you are guided by what you know, you say, I know how to differentiate this function, but to differentiate x to the power 7/3, strictly speaking, you haven't established the formula. Do you understand my point? Strictly speaking, you haven't established the formula. It happens to work just as everything else worked. But that might be by accident. You already made a mistake last time, and many people, when they see product rule, you just right away take the derivative of first function multiplied by the derivative of second function, and that is entirely wrong. Good? You understand my point, guys? And it's not even about you can memorize the one formula or another. What I try to teach you, and it's very difficult to teach, what I try to teach you is to use calculus to discover new things. Right? You might find this product formula somewhere in the book and just copy it, or you just make a computer take the derivative. A computer already has it programmed. But what's calculus? It is when you are applying it to your philosophy and your thoughts to solve problems that you have never seen before. That's what you do in physics. Okay? Okay, guys, so before I move on, everybody understands that point that I made? Do you understand my point? Yes, please confirm. Good. I know it's like a lesson, Monica, but yes, so great, great. You can ignore it if you want to, right? So in other words, you can take the derivative as I showed on the whiteboard. But here, guys, one last question regarding products. Not last, just but if I have f times, if I have, let's see if you can establish this, if you can figure out this formula again, f times g times k, and I take the derivative. What is it in terms of f, g, and k? Can you guess what will be the formula? I think I already asked you that, but let's do it one more time. Come on, guys, as quickly as possible. I want to see it. Wonderful. It's pretty easy to guess what happens here. It's that it's the traveling derivative. The derivative moves from one function to the next. Yes. And here is the formula written out. And here again, I go and establish. You see, you always try to establish. So then we made this observation. How do I calculate higher order derivatives? And there is a very fascinating pattern. Look at it. I take derivative once. It's f prime g plus f g prime. Now to take two derivatives of the product, it's like one derivative of this expression. And I get, once I calculate, two derivatives times g plus two derivative plus 2 times f prime g prime plus the two derivatives of g. Notice that the derivatives always over f and g always add up to 2. And if I take three derivatives, I get this formula. And if you look at it, there is a similarity to multiplication. It's x plus y. This is x squared plus 2xy y squared. And this is x cubed 3x squared y, 3x y squared plus y cubed. Do you see the relationship? Look at that formula and look at that formula. Can you see this line and that line? They are in some sense very much the same. Yes. So product rule does behave like a product, like multiplication. It's actually what happens here is that you have operations no longer with points, but actually the points are functions here, right? So you have a space where instead of a geometric point is actually a different function. That's a type of, let's call it functional analysis. Very kind of fascinating subject. It is the subject that you want to learn if you want to understand quantum mechanics, including probability. Okay, so so here is how we can establish this. This delta f delta g means take the derivative of f once, take the derivative of g once is this one. Okay, so then when you square it, it's this expression. And that allows you to, I can show you how to quickly calculate powers, right? So when you're expanding powers, you have this Pascal's triangle. I'm sure that if you took precalculus, this Pascal triangle was presented for you, right? It's part of the binomial theorem there, right? So what you do is you write 1, and then that's the top of the pyramid. Then you write 1 and 1, and then you begin. Then the next layer, you write 1 here, and then in between those two, you add them up and you get 2, and then you write 1. So those are the coefficients of square, right? It means x squared times 1 plus 2xy plus y squared. And then the next layer is for expanding 3 powers, right? So it's 1, and then the sum of 1 and 2 is 3. And the next, you always put the next number between two numbers above it. Yes. So then next is again 2 plus 1 is 3, and then it's finished with 1. So that means, and then I'll show you with x to the 4. So then the next layer will be you put 1 here, and then between those two numbers you add them up. Sorry, between those two numbers you add them up, you have 4. Between those two numbers you add them up, you get 6. Between those two numbers you add them up, you get 4, and then you put 1. Do you see how it works? always you just expand the base of the pyramid, and then the next number is between two numbers directly above it. Good. So this is guys, this is, let's say, what the expansion means. Let's say if I want to expand x plus y to the 4, I quickly know it's 1 times x to the 4 plus 4. I reduce 1 power of x and give it to y, plus 6. I reduce again and give it to y. Do you understand the powers, how they work? It's 4, 3, 2, 1, and x to the 0. And those are the coefficients. Good? Okay, guys? Can I ask you to find the third derivative of x to the 5 e to the x? The product, but applied three times. Can you do that? And you can do that quickly if you understand the coefficients, yes? So get the coefficients and see if you can get the derivative of x to the 5 e to the x 3 times. Oh, great. Somebody. Okay, Kirill, you have something there. Okay. Interesting. Come on, guys, calculate. You can do it. Write on a scrap of paper inventory, right? Because you will have to differentiate this function several times and this function several times, yes? So write the formula in general, and then you can plug in the values. Come on, guys, come on. Come on. Did you understand, guys, how to carry this operation? So what you have to do when you take three derivatives, symbolically, you have to cube a derivative of f plus derivative of g. Yes? So this is derivative of f plus derivative of g cubed. I can use Pascal's triangle to carry out the operation. Yes? Pascal's triangle to carry out the operation. So those are the coefficients. You just draw the Pascal's triangle. Here are your coefficients for cube. 1, 3, 3, 1. So that means it is the derivative, triple derivative of f plus 3, 2 derivative of f, 2 derivative g, plus 3 derivative f derivative g squared plus derivative of g cubed. So here let's take inventories. Essentially, derivative of e to the x are all the same, right? So the dg, or this is my g, derivatives are all the same. Derivative of f, one derivative is derivative of x to the 5, it's 5x to the 4. Second derivative is 5 times 4x cubed, which is 20x cubed. Another derivative, the third, is 5 times 4 times 3x squared, which is 60x squared. So this part understood. The derivative of f is my first function. This is f, and that represents the derivative of f. Are you with me, guys? I say f, derivative of f, but I see blank screen and I don't know, maybe you lost consciousness already, which is what I often imagine. Good, do you understand? So that's the expansion. And so then what do you do? Look at it. So what do you do? Then the triple derivative is then just the derivative of x cubed. That's what this means, right? Triple derivative of x to the 5 times the other function intact plus 3 times the two derivatives of x to the 5 times one derivative of e to the x plus 3, one derivative of x to the 5, two derivatives of e to the x, plus finally 3 derivatives of e to the x. And then when I carry it out, I already have all the components. Derivative of e to the x is very easy. I don't need to bother. It's just what? It's 60x squared e to the x plus 60x cubed e to the x plus 15x to the 4 e to the 4 plus e to the 4. Right? So in office hours, I do have to move on, guys. But in office hours, if you stay with me, we can practice more such problems, right? It's something extremely simple to apply. And something that if you actually bother understanding the material, you come up on your own. You understand? You actually are faster just in terms of your ability to process this information. If you're not learning it this way, you're just memorizing arbitrary facts and you're extremely inefficient about the subject. If you look at it through my eyes, it will look to you like one problem. Now let's talk about quotient rule. How do you take the derivative of f divided by g? Okay, I will leave you to verify. I mean, the question is, can you come up with a geometric argument? So here is a formula. You never saw it before. Can you realize why the derivative will be what I wrote here on the right? Can you do that by definition? You understand? So try doing it by geometry. Do you understand the stand double argument, the Cascadior argument about zooming in on a curve and seeing a straight line and then deciding what is the slope of that straight line? Right, so that's a very, very good exercise question. If you understand how to get this derivative, then you are already thinking like a calculus person. You are able to, the formulas are natural to you. They're not just somebody came and told you to use them. But so again, I leave the verification to you. This is the formula. Derivative of f over g. What you do is this. You square the bottom function. You copy the bottom function and multiply by the derivative of top function. Subtract, and now the derivatives are reversed. So try to remember this part and then that part. You understand, guys? This part and that part. Numerator looks kind of like a product rule, but it's very important to remember derivative of numerator times g, and there is a minus here. Good? So let's see if we can, this is what you pay attention. I would like you to calculate the derivative of x to the 5 divided by 2 e to the x, please. Here is your formula. So again, I do invite you guys again, after class, we can try to derive this formula or practice more examples. You do not learn this material by just listening to my lectures. It will not work. Okay, great. More of you should answer it, guys. Let's see how many. Only 4 people. There are 30 people. What about the rest of you? All right. Come on, guys. Come on, come on, come on. You can do it. All right. So here is how we answer it. Look at it, guys. I always, to remember the formula, I pay attention to the denominator. So first, the denominator is squared, and then I copy the denominator and take its derivative. Do you see? It's just because it happens to be e to the x, the derivative looks the same. Good? So I took the denominator and I copied, multiplied by the derivative of numerator, minus the derivative of denominator times numerator. You understand? So if you remember this part, I think you can remember the second part. The derivative is reversed afterwards. So that means that numerator is simply 2e to the x times 5x to the 4 minus, here derivatives don't change anything, times x to the 5 divided by squaring it, it will be 4e to the 2x. Good? So applying the formula is not too hard. Now find the derivative of 1 over x to the 5, please. You see, I want you to use quotient rule because, well, you can do it several ways. Okay, so calculate it whichever way you like. Tell me what's the derivative. Yes. All right, guys, so this is, there are several ways of solving it. One is the non-regress way again, right? What is this? This is x to the power of minus 5. So when you take the derivative, you should get minus 5x to the power of minus 6. Of course, the trouble is that we haven't verified that this formula is true. It is true, but we haven't verified so. So what you do, you can use the quotient rule. So you square the denominator. Yes, you square the denominator and copy the denominator multiplied by the derivative of 1, which makes it 0 here, right? So this is 0. Times the minus the derivative of x to the 5, which is minus 5x to the 4 times 1. So when I simplify it, I get minus 5x to the power of minus 6, which is the same formula. Okay?